30 minutes, the probability that X equals 30. So when it's a continuous distribution, okay, this is really important. The probability that X equals any number is always 0 for a continuous distribution.
Uh-huh.
Okay. So that is like a true false, something you'd see on a test quiz and so on. But the next questions obviously get a little more difficult, so we'll keep going here. So number two here, we got the length of time patients must see a doctor in a local clinic is uniformly between 45 minutes and 2.5 hours. So we really want to convert this second time to a to minutes. That's 150 minutes. Right. And then I think it's good to draw a graph each time just to visualize it. It doesn't have to be all that accurate here, but 50 to 150. And then the area of this rectangle is always equal to 1. Okay. So the height of the rectangle is something that we do want to calculate here. So the height of the rectangle, if the area is 1, the area is base times height. The base in this problem is 150 minus 50, or 100 times the height equals 1, because that's the area. So you see the height is 1 over 100. Again, not to scale. That is something you may be asked to do over and over again. That's why we're doing it here.
Okay.
Now, again, this one says the probability of exactly 50 minutes. Exactly 50 minutes. That's 0. Okay. Now this rectangle stuff will matter here for part B, but again, they're just really emphasizing, hey, do you understand that for continuous distributions, exactly means that it's 0 there. So this rectangle, very important. We're gonna use this again here in the next one. So for part B, 50 to 150 here, between 65 minutes. So 65 minutes and 2 hours, that's 120. So we want the area of this rectangle, okay? And the area of the rectangle is still base times height. The height, just like from the previous one, is 1 over 100. Okay, so the base is going to be 120 minus 65. Okay, so you can always think of your base as being right minus left. Does that make sense?
Yeah.
And then your height, 1 over 100. So this is where you got to grab a calculator. If you have one handy, please grab a calculator. Let's confirm these calculations, but you got to subtract and then multiply by 1 over 100. Let me know what you come up with here for this one, please.
115. Oh, wait, is that 170?
120. 120. So 2 hours is 120 minutes.
So 55. And then divide that by 100.
Yes.
Okay.
So you should get 0.555.
Yeah.
Is that right? All
Yeah.
right. Good. Okay, now for part C, again, you gotta really look at what it's asking for. So this time they want the weight over 2 hours. So again, we know this thing goes from 50 to 150. It's got a height of 1 over 100, but this time 2 hours, 120 minutes. So here's 120, but we don't go forever. We just go to the end, the edge there. And you're again finding the area of this rectangle. So the area of the rectangle is base times height. It's 150 minus 120. Okay, that's the base. And the height is again 1 over 100. All right.
Okay.
So,
yeah.
All right. So if you want to calculate that for us.
0.3.
Yeah. All right. All right, now for the next parts here, for part D, there's two things that it asks for.
Mhm.
So it asks for the expected value and the standard deviation. Now you've probably heard over and over again not to go to Wikipedia, but I actually think it's perfect for this kind of stuff here, because it gives you exactly what you're looking for. So, again, I'll drop this in the chat and I'll snip it in.
Okay.
But like it's a little hard to read at first because there's so much going on, but the first thing it's asking for is the mean. The expected value of X is the mean. Okay. So what is this A and B? A is the starting value. B is the ending value. All right. So it's is 1/2 of 200, which is 100 minutes. It's the number that's right in the middle.
Okay.
Okay. Now the sigma comes from the variance. So sigma standard deviation, it comes from, or it is the variance here. So we get this number, but we have to take the square root of it. So we're gonna take the square root of 1/12
Mhm.
b minus a, 150 minus 50 squared. Now this is a good time to ask you if you have a formula sheet or a reference sheet, or if you'll be given one. It would be,
Yeah, he does give us one.
so it'd be good to have that, on the homework, looking at it, okay, there's that formula for variance, there's a formula for mean. That way, on the test what you're looking for.
Yes.
So the only way you can go wrong here is if you put this wrong into your calculator. Will you give this a try and see what you come up with?
Yeah. Hold on, I just have my phone calculator right now.
Okay, yeah, probably want to have something a little more
Yeah.
consistent with what you'll be using in class for this. So in that case, I would at least recommend, because you got to do these calculations. Me doing them isn't all that helpful. Let me put in. Let me get this to you. So whenever students don't have one available, I always suggest going here to the Desmos Scientific calculators. I'll drop that in the chat.
Okay.
And you can enter it a little bit more consistent what you would normally think. You've got to get comfortable doing these calculations. That's why I'm asking you to do them today.
All right, I'm typing it in right now. Let me see if my calculator's charged right now.
Okay.
I'm having trouble with that one. 1 second.
Yep. No problem.
Okay, I got it.
Okay. All right, so let me write the answer here. Definitely want to keep moving through this, but 28.87 is what I'm seeing. That is after you take the square root. So that's the answer there. You may also want to check these as we go in case there's an error. Meaning enter these in, and if there's an issue, just let me know so we can go back and look at it.
1 second.
Okay.
Sorry, I was having my roommate help me enter it.
And if you, I've got a TI-83, so I can help you. I can show you that also as well. Whatever you've allowed to use in the test, I can try my best to emulate here.
Okay,
Okay, were you able to get this number?
I did, yeah.
Okay, fantastic. Okay, so it definitely, it seems like a small thing, but when you get to the test there, it's all on you to be able to do it. So I'm going to move on to 3A. If you need us to, we can always go back and recheck one of the ones we just did.
Okay,
This one says the length of time it takes students to complete an examination is uniformly distributed. So we're really emphasizing the uniform distribution. The lower limit is A and the upper limit is B. Now, again, like I really like Wikipedia for this, and actually for a lot of other things, but this is asking for the PDF, what's called the probability density function here. And you can see there is, and you got to just know what to look for, but it's telling you what goes in here. And it's 1 over B minus A, 60 minus 35, which is 1 over 25. Okay, so that goes in that first box there. Is that okay? Clear? Maybe you're muted. You are
Oh,
muted. If
sorry,
you're,
yeah.
just let me know. It's a, you don't have to be on, or you don't have to be on the call, but on the voice. But okay, so part B, there's a couple of ways to do this. They might be showing you something slightly different in class, but I'm gonna recommend drawing these rectangles again, just for that visualization. So it goes from 35 to 60. The height is 1 over 25. That's what we calculated in part A. And this time they want it from 40 to 45. So they want this area right there. The area of the rectangle is base times height. So that's 45 minus 40. And the height is 1 over 25. Okay.
Okay.
So again, if you want to calculate that for us.
Yeah. Should I put the parentheses in?
Yeah. So in terms of how you enter this calculator, it would be parentheses 45 minus 40 times 1 slash 25.
.2.
Yes. Okay. Part C here.
Do you want me to enter the answers in or?
Yeah, I'm not, it
Okay,
would slow us down if I had to enter them in, because it'll refresh every time, and
okay,
but you're welcome to
let me, Number one was 0, right?
Yes, we go back up here and yeah, 1 was 0,
And then A was 0,
1A was 0. Yep.
B was 0.55, C 0.5 for 3.
0.3 for part C. Part D is 100 and then 28.887.
Okay. And then the next one was 1. Number 3 was 1/25 or oh no.
A is 1/25. And then B we found 0.2. I think we're up to C now.
Okay.
Okay, so here we are, we're up to C here. Compute the probability that the student will take no more than 35 minutes to complete the exam. So 35 to 60 again, you got to be careful here. More than 35 would be everything to the right of 35, but no means to go the other direction. And since it's right on the edge, we know that if it's outside of this box, it's 0 basically. So if there's nothing inside the box, it's 0. Since it's right on the edge of the box, it also takes on the value of 0.
Okay.
And that it's kind of related to number 1. All right, now part D is the expected value. Okay, so we had a formula for this in part previous problem. So it's 1/2 A plus B, 1/2 35 plus 60. And so you can in terms of how you would enter this calculator, you can do 1 divided by 2 parentheses 35 plus 60. That will work.
47.5.
47.5, good. And then part E is asking for the variance. And we did this in the previous problem. Sigma squared is 1/12 B minus A squared. So it's 1/12 60 minus 35 squared. So you do not have to take a square root because it's asking for the variance.
Enter that in.
Yeah.
$52.8 or 1.
2 decimal places. 2 decimal places. So it should let me check it here. Yeah, 52.08 looks good on that front.
Okay.
All right, so the next problem, I just did a quick look ahead. They can be done using your calculator directly or using tables. Do you know what kind of calculator are you allowed to use in class?
You can use the graphing calculator.
Graphing calculator? Okay, that's good. All right. So I'm going to grab my
It says
TI.
B, C, and D were wrong. for number 2.
Number 2.
What
This one back here, the length,
was that?
the length of time patients must wait to see a doctor.
Yes.
Okay. Is there any chance the numbers changed with you logging in versus me? Oh, you know what? I do see where it is. It's right here. Yeah, so it's 45. There, that's the issue. 45. So it does change all the answers here. So here's what it changes. This becomes 105. Like that. And this goes to 105 over here. So we just need to recalculate this. So let's go 120 minus 65 divided by 105. So this is gonna be 0.53. 0.53. I'm sorry, 52. 2 decimal places, 52. And then B will also change because that's 45. And then this is 1 over 105. Okay, so we got to redo this calculation on the right. 0.29. And yeah, it does affect all of these. This is this number 45. 45. So this one is 195. Right. Yeah, good. Glad you entered those because it'd be very frustrating later on to find out that they were wrong. So we got 97.5 here. And then yeah, again, please check these as well. And then the last one here, square root 105. 30.31. Okay, go ahead and give those a try. Hopefully that satisfies.
Yep, those are all right.
Okay. All right, so I'm gonna, so we left off here at this problem with the standard normal. What I'm gonna do is
number 3 is all right. So
what's that?
number 3 is all right.
Oh, good. So what I'm gonna do grab is share my virtual TI-83 so that we can you can see how to do this because you're gonna prefer to do it on the calculator here. So let me new share this. All right, so if you're seeing my screen, you see a virtual TI-83, hopefully. Yes, no, maybe.
Yep.
Great. Let's so let me just recall where to go. I think it's under second distribution. Yeah, so second distribution, you want to choose normal CDF. Oh, no, doesn't do that. So yours is going to can you tell me what you see? Go to second distribution, normal CDF. Can you tell me what the options are?
Where's distribution?
Yeah, second distribution under vars.
Okay. Then normal PDF.
Yes, CDF, not the PDF.
Okay.
What do you see on your
It says
screen?
lower.
Okay.
Upper.
Okay. So you're going to put in 1.8 for your lower, 2.5 for your upper. What's the next one that it asks for?
2.5. And then the U.
So that's going to be 0.
0.
And then next one's like a sigma.
Yeah.
Okay, that's going to be 1. Anything else?
Paste.
Yeah. Okay.
Do I just hit enter now?
Yeah, just hit enter. And it should calculate the number that
1.8 dash 2.5 dash 0.1.
So hit enter and it should give you this value here.
Yeah, 0.029.
Yes. So if you look on number 4, you'll see that that's letter A.
Yep. Okay.
Okay, so for the next one here, it's going to be the same thing. So you have a choice. You can either go back to that screen or you can edit the one that you've been working on. Actually, let me go back to this because I need to show you what this actually is, because it's sort of magic at this point. Why does this even work? So here's what's going on. Let me get rid of this. So there's this normal curve. You probably saw this in class. Is that right?
Yeah.
Okay, so 1.8, 0 is right here in the middle. So 1.8 we'll say is there, 2.5 is there. We just found the area right there. That's 0.02997 from 1.8 to 2.5.
Mhm.
All right, so now in the next one here, it wants to find the probability that Z is greater than negative 2.15. So again, 0 is right in the middle, negative 2.15, we'll just say it's right there. They want to find the area, everything to the right of that. Okay, so when we went to your TI 83 or 84, you had to provide the lower, the upper, the mu, and the sigma. Is that right?
Yes.
So the lower is going to be this minus 2.15.
Okay.
Okay. Now in the previous problem, they gave us an upper. So what some students do when they don't know the upper is they use 10 to the 99 power. 10 caret 99. Now that's a little extreme, but that is you essentially going out to infinity. So this is still 0 and this is still 1.
Okay. And then
Okay.
would I just do x2 for
What,
1099?
10, you're going to use 10 and the caret symbol. So the caret symbol is above the division.
Oh, okay.
I can show you that as
I got
well
it.
on the screen. So let me
And then
get
for the
this.
mu.
Mu is 0, sigma is 1.
It says there's an error when I tried to go through.
So when you're doing your minus, make sure you're choosing the negative operator, which is next to the enter button.
Oh, I see. That's what I did.
All right, so I'm doing it on my screen here. And my answer is 0.9842.
That's what I got.
Great. Okay, so the calculator is so useful here.
Yes.
That's why I was asking, because you can't use a calculator. We got to do it another way, which, could or could not be an issue. Now, the 6, you think, okay, I got it. And then 6 is a harder problem here. So I'm cutting through some of the stuff that you should be seeing in class, but you
Uh-huh.
you can pick that up there. So this one has a mean of 6 this time, not 0. So that means 6 is right in the middle. All right, so your mu this time is 6 and your sigma is 3.
Hmm.
5.51 and 6.41, they're here. 5.51, 6.41. You're trying to find the area in between. So your lower is always you can think of lower as being the left. That's 5.51. Your upper is the 6.41. Your mu is 6 and your sigma is 3. So you want to make those adjustments on your calculator there.
Enter.
Yes.
0.119.
Is that one there? It is. Good. I'm a little slower on my side. So let me yep. So 7 is very similar. You snip that in. Draw again, just like with the uniform distribution, drawing it is really critical to knowing where it is, what's going on here. So again, this one has a mean of 8. So the 8's right in the middle. And then we want to go greater than 11.74. So let's just say 11.74 is there. We want everything to the right of it. So your lower is 11.74. Your upper is infinity essentially. So you go 10 to the 99. And then your mu this time is 8. Sigma though is not 9. Sigma squared is 9. So you have to take the square root of 9 to get that because it's giving you the variance, not the standard deviation.
Okay.
So go ahead and enter this in, see what you come up with.
Square root 9 equals 3.
Yes. If it didn't work out perfectly, you would just type in the square root of the number and it will give you everything you want.
How do I do the equals?
Oh, you don't. You just type in the number.
Oh, 9, 3.
Well, just
Oh.
3, just the sigma.
Oh, okay. No square root then?
No, because so my what I'm saying is you can either enter it as the square root of 9 and let the calculator do it, or you can it's 3, so you leave it as 3. You have to choose.
Okay. 0.1063. Or 0.1063. Yeah. I got that one.
All right. So if you get a number that isn't there, you obviously want to recheck your calculations, right?
Yeah.
But hopefully on the exam, was this exam similar to the questions you were seeing on
Yeah.
on the homeworks? Okay, that's good news. All right. So
There's the
8.
practice exam that's like identical,
Oh, cool.
but yeah.
Cool. Yeah. Well, I mean, that would be, good to go through and even schedule a lesson around to be able to know how to work through those.
Yeah.
Okay, so X is normally distributed with a mean of 15, standard deviation of 4. This one though says the probability that X equals 20.53. So the distribution that we've been working with, the normal distribution, is continuous. So what does that mean for this one right here? It's just like the first one we did today.
So that's your lower.
No, the first one we did today, all the way back to the beginning. If it's a continuous distribution and asks for equal, the probability that X equals a number is always 0 for a continuous distribution.
Okay.
That's where you can run into issues, is you can try to do something and the calculator might give you something that seems reasonable, but this one is 0.
0. All right, I got that one.
Okay, now this one is it's different than what we've been doing. So in the previous problems, you've been finding the area. Like in each of these problems up here, you're finding this area, finding this area, finding the area. Now in this problem, they're giving you the area. Okay, they're saying the area left of the z, so left of some number, which we're going to try and find. This area over here is 0.2676. Okay, so this is like the going backwards. So we're going to go back to the calculator now. And I probably need your help because I don't know. I don't know if this is going to work out. So second distribution, This time you want inverse norm.
Okay.
Okay, can you tell me what the,
Area.
okay, so the area is 0.2676.
Okay.
0.2676.
And then U.
Okay, so the mu in this problem is 0. And then does it sigma the next one?
Yes.
Okay, so that's 1. What else does it ask for? if
Tail,
anything?
left, center, right.
Okay, so you want left tail. If you go back to our pictured left, does it tell you to paste it?
Yes.
Can you tell me what the thing after the third comma is when you paste it?
Left.
The word left?
Yes.
All right, let me see if this will do it. It did. Okay. All right, let's see if mine works. Doesn't like it. All right. What did you get for that?
Just hit enter again.
Yeah.
Negative 0.62.
Okay. And that's one of your answers there.
Yeah.
Let me so again, my thing is limited. It's let me do this another way. Just to check 0.2676. Yeah, looks good. Okay.
Okay.
So you have to know which buttons to push. It's not hard, but if you push the wrong buttons, right, it'll give you an answer that isn't helpful. So let's look at a new problem here. I'll go back to the other screen. All right. All right, so this time it's to the right of Z. So you draw your normal curve, and you might be wondering, well, how does Matthew know that it's right there? Well, 50% is to the right and 50% is to the left. So 0.13 is not that much. So I'm assuming it's over there, and it says right of Z. So this time in your calculator, you're just going to have to change your tail to be right-tailed when
Okay.
you're typing this in.
So my first number would be 0 for area would be 0.
Here's the area. The area is 0.1314.
Do I put the 0 before it?
It doesn't matter. Up to you.
All right. And then the U would be 0.
Yes.
And then 1.
First
And
for sigma, yes, and then a right
right.
tail this time. Yeah.
1.119.
So 1.12. Good.
Sweet.
All right, so new problem here. So this time they're giving you the area between two values. They're saying that there's two Z values. One is positive and one is negative, and the area between is 0.7415. So what that means for you is you're gonna want to enter this in the calculator, but you can use between or middle. I don't remember what it said in the calculator, left, right, and then between or middle,
Mhm.
and see if any of these numbers appear.
Came up with a bunch of numbers. Oh, I think it's the third one. 1 point.
So what did you get? What does your calculator tell you?
It gave me a negative 1.129.
Yeah,
And then
that's fine. Yep,
but then it gave me a positive.
that's fine. That's fine. Yeah, so you just got to kind of know what to look for on that.
Okay, I got that one right.
All right, really good. Okay, so 12 is very similar. All we're doing here is changing the mean and the standard deviation. So it's very similar. Let me snip that in here. Okay, so they're telling you that the weight of football players are normally distributed with a mean of 210. So that's your mu, and a standard deviation of 25. And they wanted the probability that a player weighs more than 260. Okay, more than 260. So this is the first type that we've been doing. Okay, this is not like the last three. Okay,
So
this
this
is
is the second distribution, normal CDF.
normal CDF. That's right. Okay, so in normal CDF, you need to know the lower,
Mhm.
the upper, the mean, and the sigma. So the lower is 260 because it says more than 260. The upper is 10 to the 99. The mean is 210 and the sigma is 25.
Zero point, uh, let me see, 0.0227, 228, okay.
That's pretty good.
Got it.
13 here. So again, similar problem, different numbers.
Mhm.
The weight of football players is normally distributed with a mean of 180, standard deviation of 25. So we know that 180 is right in the middle. What percent of players are between 155 and 205 pounds? We want the area again.
Mhm.
So you need your lower, your upper, your mean, and your sigma. So the
So the
lower
lower
is
is
one. Go, sorry, go.
150,
Yeah,
155,
the upper
there
is
205,
good,
the U would be 180,
good.
and then what's the last one called again?
Sigma or standard deviation.
Okay,
They use Greek letters for population parameters.
and what would that one be?
25. So
Okay,
you almost want to check, like, did I use all the numbers that are given? Now you're going to get an answer that's a decimal. These are all percents. So you want to take whatever your answer is and multiply by 100 to convert to a percent.
I got 0.6827.
Okay, so you multiply that by 100 and that's 68.27%.
I got that one.
Good, really good. Okay, next one here. You will need. Okay, starting salaries with a certain degree are normally distributed with a mean of $30,000. So that mean goes right in the middle. Standard deviation of 2,500. So that's your mu, that's your sigma. What is the probability that a randomly selected individual with degree can get a starting salary of at least 25,000? So here's 25,000. Does at least mean to the right or to the left?
To the left.
So that would be at most. At most is less than or equal to. At least is a greater than or equal to. So this is left. This one is right. So we want everything to the right of it. Okay. So this time your lower is 25,000. Your upper is 10 to the 99. Your mu is 30,000. And your sigma is 2,500.
One says 0.579.
You missed a zero somewhere on one of these. So check your lower 25,000, upper
I'm
10
doing
to
on
the,
normal PDF. Right? Yeah.
yes, normal CDF.
25,000, 1099, 30,000. Oh, and then 2,500.
Yes.
Okay, 0.9772.
Good. Really good. All right. So that's going to take us to the end of our lesson for today.